Hi, welcome back to another OCR MEI past paper walkthrough. Today we're doing Core 2, Section B for the May 2013 paper. So let's go all the way down to Section B. Question 9, Figure 9 shows a sketch as follows. Y equals x cubed minus 3x squared minus 22x plus 24 with the line y equals 6x plus 24. Differentiate y equals x cubed minus 3x squared minus 22x plus 24 and find the x coordinate of the turning point of the curve. You're given that the line and the curve intersect when x equals 0 and x equals minus 4. So find algebraically the x coordinate of the other point of intersection. Use calculus to find the area of the region bounded by the curve and the line y equals 6x plus 24 for minus 4 for x between 0 and negative 4, which is the shaded region here. Okay, so let's start with first part. Differentiate this expression to find the two points of turning points or stationary points. So first dy by dx, and this is just a normal polynomial, so you just use the normal differentiation rule, drop the power and power take 1. So for x cubed you get 3 times x, 3 minus 1 is 2, so 3x squared. Subtract by 3 times the power, which is 2, that get you 6. X 2 minus 1 is 1, so you get minus 6x. Then you take 22 and x to the power 1, drop the power is just the same coefficient, and x to the power 1 minus 1, which is 0. So x to the 0 is 1, and so it is just minus 22. Plus 24, x to the 0. When you drop the power, you get 0 multiplied by that whole thing, so you get 0, so the term disappears. So I've got this dy by dx expression. We now just find the two stationary points, which are 0 equal 3x squared minus 6x minus 22. So the way to do this, to find x, is just to use the quadratic formula. This quadratic looks pretty horrible, and I don't think it can be factorized into whole numbers. So x using the quadratic formula, minus b is 6 plus or minus the square root of b squared, 36, minus 4ac, and c is negative, so you can add that. 4 times 3 times 22. And all of that divided by 2 lots of a, which are 2 3s, so 6. Now this one, the root, when you type it in your calculator, is 300. So 6 plus or minus the root of 300 over 6. And so root of 300 is also 5 root 3, 10 root 3, sorry. So this whole expression is 6 plus or minus 10 root 3 divided by 6, and you can simplify this, or you can just actually type it in your calculator to get the two decimal places answers, because for particular reasons C2 like to ask you for non-exact answers, which will never happen at higher papers. So the two values you should get is 3.8 8, 9, 2 dp, and if I do subtract instead of adding, you should get negative 1.89. So these two are the two x coordinates of this these stationary points. So part 2, I need to find this the x coordinate of this single point algebraically. So the fact that they are two lines intersecting makes it so that I need to do a simultaneous equation. So 6x plus 24 is equal to that expression, and now we need to try to solve for this for x. So both sides have a plus 24, so we take those out because we subtract both sides by 24, and we have 6x equals x cubed minus 3x squared minus 22x. And the tempting thing to do here is to divide everything by x, but that is not viable because this entire domain consists of all real values of x, and it includes 0. So if you divide by x, then you lose information of the curve. So what you need to do is to move everything to the right so that you get 0 on the left. So x cubed minus 3x squared minus 28x is 0. So now we need to do factorization on the right. Since every term has an x, we can take x out and leave everything in brackets. And that is factorized. Okay, 28 is 4 times 7, so this can be further factorized into x minus something, x plus something, because it's a negative 28. So the signs are different, and the negative value is larger. So we know it's 4 and 7, so 4 is positive, 7 is negative. So this is the factorized version, and therefore the values for x where this holds true is when x is equal to 0, when x minus 7 is 0, and when x plus 4 is also 0. So there are 3 x values: x equals 0, x equals 7, and x equals negative 4. And it's given by the question 0 and negative 4, so the remaining x value is the 7 over here. So x is equal to 7. And for part 3, we need to find the shaded area. There are multiple different ways that you can go around this, but the easiest will be just to integrate the curve between x is 0, x is minus 4 for y equals x cubed minus 3x squared blah blah blah, subtract by this triangle. And this triangle can be done by normal algebra, so you do not actually need to integrate a complementary lines. It's only necessary when you're doing two curves overlapping each other. So I'll do the easy method for this video. So y equals x cubed minus 3x squared minus 22x plus 24, and to find area you always integrate between the x-axis and the curve. and we need to set a boundary condition, the larger number at the top and the smaller number at the bottom. And this is for the x-axis, so we use the x values, so x is 0, x is -4, and throw in the curve y, and remember the dx because mathematicians love their syntax. And just do integration. Integration, similar to differentiation but reversed. Add the power, subtract, divide by the new power. So to integrate this, x cubed goes to x to the 4 and divide that by the new power. Subtract by x cubed, 3x cubed divided by 3, that is x cubed. Take 22x squared divided by 2, add 24x to the 1 divided by 1, and the c doesn't really matter because we have boundary conditions, and so the c will cancel out itself. So that should be the area that we are looking for, plus this triangle. If you put 0 in, then you get 0, 0, 0, 0. So 0 is our first value. Subtract by the lower bounds. So this is a -4 to the power of 4 divided by 4. That's a lot of 4s. Minus 3 over 3, that's 1. So I have a -4 to the cubed. Take 11 times -4 squared. Add 24 lots of -4. And that is a massive expression. So let's deploy our calculator. So -4 to the 4 divided by 4 is just -4. Well, it's actually plus 4 cubed, which is 64. Make sure you do all the signs correctly, and this negative is outside, so like make sure you bracket everything. When you're typing things in the calculator, it's really important that you do type everything incorrectly. -4 cubed is -64, so this is a negative, so you add 64 instead because it's double negative. Minus 11 multiplied by -4 squared, this is a positive 16, so we take 16 times 11 is 176, and you finally, over here we have 4 times 24, which is 96, and it's a negative 96. And when you do 128 minus 176 minus 96 is minus 144, but there's a negative outside, so you get 144 units square. But this includes this triangle, and we need to take that off. And the triangle have height 24, width 4, and by triangle rule, it's base times height divided by 2, and therefore we get 48 units square. And so the total area is just 144 take 48. This is actually shaded area. this is the total area, and this is the triangle area. So the shaded will be 144 takes 48, gives you 96 units square. And that is part 3. Question 10, we have a quadrilateral ABCD and 1A, calculate AC and angle ACB, and hence calculate AD. And finally calculate the area. So this is just sine rule, cosine rule, and yeah, that should be it. And also Pythagoras theorem. Then the second part is the shape of fence used is shown as this, and EH is a sector of a circle, and it's 1.1 radians. So make sure your calculator is in radian mode, and calculate the area of this panel. So for this one, it's just a lot of trigonometry calculations. Make sure you have your calculator ready, because we're going to do a lot of calculation here. And first, find AC. For this, we can just do Pythagoras, because we have 2 lines and a right-angled triangle. So AC squared is equal to 7.5 squared plus 12.8 squared, which means that AC is, put it in your calculator, make sure to square root, and you get 14.83543 or 14.8. So for this question, you cannot actually use accurate values, and they're not like structured nicely, so that there will be answer tolerances. As long as you're in the error range, then you should be fine. But make sure to lower or limit your error as much as possible. So I've got AC, now we find ACB. Using the larger value, the more accurate value of AC, or your stored answer on your calculator, and if you know the memory function, then go ahead and use it. Me, for one, I do not use the memory function, so I just usually do as many decimal as I can, or I just type in the entire equation. So ACB, you can use just normal tangent actually. So tangent of theta is just opposite divided by adjacent, and for this particular right-angled triangle is 12.8 divided by 7.5. And so on my calculator, arctan of 12.8 divided by 7.5 is 59.6 degree. 3 significant figures. Now we find AD. How do you find AD? Well, you just use sine rule. Because we have AC, we know the ratio between sine 35 and AC. So let's write down the sine rule. Sine, well, I'll just put down the expression in terms of the question, just for the sake of it. Sine of angle ECD divided by AD. So we know AC, we know ACD, well, we do not know ACD, but we know ACB, so we can find ACD by taking ACB off from 155. So 155, take that, is 95.367. So sine of 35 is divided by 14.83543. Again, use as many decimals as you can be asked to, but the more accurate you are, the less likely they will reject your answer. And for me, I do not really, I won't be rejected anyway, because this is a video, this is not my A level, or yeah, it's a C2 paper, so it is A level. I thought for a second it's GCSE for a minute, sorry. So rearrange this to get the following expression. And all it's left for us to do is just type in all the answers, our values. So 14.83543 divided by sine of 35 gives me 25.751. That's AD. So I will say that this is 25.8. I will just add another few decimals so that in the long run I again minimize my error for when I do my part B bits. So part A is done. Now part B, find the area. I need to find two stretch of area because I cannot actually find the area of the whole thing at once. We need to split it in half. So let's split off AC. So let's first find the big triangle because the small triangle is easy to find. We'll do the hard bit first. So for this bit, we know AD in the form of here. We know that we know AC and AD, so we want angle DAC or CAD to use the half AB sine C equation. But the thing is, we do not know that angle. It's not 80 because 80 is DAB instead of C. So we need to find CAB first. So angle CAB is just 90 take away ACB, which is 30.4 degree. And since we have all these values, let's just use the ready-made numbers. Half AB, which is 14.835. I'll just use the rounded numbers, and I will actually type out the longer version, but writing it down is a bit slow. Sine of 30.4 will be equal the area, so let me just take a second. My bad, this is not 30.4. 30.4 is this angle, this small one. I need the big one, so it's 80 take 30.4, which is 49.6, not 4.96. So this is not right. And now I will just redo my typing. I'll just use the round down version of the value for angles to save me some time. And that gives me 145.466 meters squared. And now I need to add the small triangle. So this will be 12.8 times 7.5 divided by 2, which is 48 exactly. And so the sum of the area will be the sum of both of them, which results in 193 meter squared, 3 significant figures. Okay, for this one, it is a radians question, so I need to turn my angle unit to radians. And the thing about this question is that, first of all, it is a area of a sector, and also a two triangles without much information. The only thing you know is MG and FM because they're half of it, half of FG. So this is 0.9, this is also 0.9, and you know that this entire thing, the angle, is 1 pi radians. So pi subtract by 1.1 divided by 2 is the angle of HMG and angle EMF. I can think of a really big physics joke right now, but I'm gonna hold it in because it will literally cringe everyone. So I've got this angle, and I should be able to find the area of these two triangles now. The fact that I do not know HG means that I need to find MH. Means that I need to find out HG. Or I can find that instead, but put that aside. It's actually better to find MH and EM because they are the radius of that circle. So let's do that way instead. So the trigonometry still works with radians, so we know that cosine of 1.021 is equal to the adjacent divided by hypotenuse, or so that will be a 0.9 divided by radius. I just put it R, so R is 0.9 divided by cosine of 1.021, and cosine of this angle is just 0.522, so 0.9 divided by that will give you R is 1.72187. This is in meters again. So the area of two triangles is 2 lots of half AB sine C, and the 2 lots and the half goes, so it's practically just AB sine C. So I have 0.9 times 1.72 sine of 1.021, and that gives me sine of 1.021. I think it's 1.0207 more accurately. So it's 1.321 meters squared for just those two triangles. And now we need to find the sector area. So sector area is just pi r squared multiplied by the angle. And if you're not familiar with radians, one full circle is 2 pi, and the denominator of this fraction will be the middle radian, so 1.1. It's similar to, say, if this is a 60-degree angle of a 360 degree circle, then you do 60 divided by 360. It's the same for radians, but you just use different numbers, and 2 pi is a full circle. And so the pi goes, this is the good thing about radians, you do not deal with that pi usually. And see, radius is 1.72. R squared times 1.1 divided by 2 is just 1.630. 0.066, and I can just add these two together. Sum of the area is 2.95 meters squared. So that's this question done. And the last question of this paper is another one of these log type questions, and these are usually the bane of most students because they do not know how to do it. It's relatively simple if you understand the concept, but it is actually pretty hard. So a hot drink, when first made, is 65 degrees higher than the room temperature. The temperature difference is D, and D decreases by 1.7% each minute, and show that after 3 minutes D equals to this, to 3SF. Write down expression for D at time n, n minutes after the drink is made, where n is an integer, and show that D is smaller than 3 and have to satisfy this equation. And so find the least integer value of n where D is smaller than 3. That's a whole lot of just not English, but you'll know how to do it by the end of this video. Temperature difference at time t after the drink can also be expressed as this for some time constant k. Use the value d is 1 minute to calculate k and find temperature after 25.3 minutes. So part 1 is relatively straightforward. It's basically just iterate 3 times of what every 1 minute does. So at t equals 0 minutes, it's 65 degrees Celsius. Then per minute, it goes down by 1.7%. Goes down, so it's 1 minus 1.7%. And this answer is used, and another minute pass, use that answer multiply by the same factor again, and that's the second minute, and do that the same for the third minute and show that it is 61 point something or whatever. So let's do that. So 100 take 1.7 is just 98.3%. So every time you multiply by 93.8%, and because we're multiplying it by 3 times, so this is to the power 3. And so you have 65 times 98.3 to the power of 3. It gets you 61.741, and so rounded to 3SF, 61.7 degree Celsius, I think. Yeah. Okay, so I need to first, for part 2, find the expression for which for D in terms of n minutes. So D is equal to the original temperature, 65 degree, multiply by the change in temperature, which is 1 minus 1.7% to the power of n. That is the case for what this scenario gives. So 1 minus 1.7 is 0.983 to n, and that is your expression for part 2. That's 1 mark. And now part 3, I need to show this when D is less than 3. So let's do that. So D is less than 3, and therefore 3 is larger than this entire expression. And since for this one we see them use log, so let's just log base 10 of everything. Log base 10 of 3. I just didn't write base 10 because normally if you write log, it means base 10 because we have humans have 10 fingers or something like that. It's just instinct, really. So log of 65 times 0.983 to the power of n, and we know that log rules. This thing is just log of 65 plus the log of 0.983 to the n, and this power can be dropped so that I get log 3 is larger than log of 65 plus n log 0.983, and by rearranging, take log 65 from both sides, you get log 3, subtract by log 65 is n log 0.983, and so divide both sides by log 0.983, and turns out because log of base 10 of 0.983 is a negative number, you do flip your inequality sign. Most people will forget to do that. And so log 3 minus log of 65 divided by log of 0.983 is smaller than n, and that is exactly what they are asking for. And we now need to find the least value of n at which this is true. So let's use equality instead. So first of all, no, actually you just type in all the values in your calculator, you don't change the inequality sign. Log of 3 subtract by log of 65 divided by the log of 0.983 gives you n is larger than 179.38 blah blah blah. And because n can only be an integer, it is the smallest integer that's bigger than this thing, which is n equals 180, so that's 180. And finally part 4 for D, we need to use t equals 1 minute using the previous equation to find what k is. Then you use that equation to find t is 25.3. So let's start with t equals 1. So if t equals 1, d equals to 65 times 0.983, which is 65 times 0.983 is 63.895, and so 63.895 is equal to 65 times 10 to the minus kt, and divide both sides by 65, you get just, well, 0.983 is 10 to the minus kt. And if you log both sides, then minus kt, it's minus 7.446 times 10 to the minus 3. And so because t is 1, minus k is that, and so k is just 7.45 times 10 to the minus 3. Now we use this value as k and find d when t is 25.3. So d is 65 times 10 to the minus k times 25.3, which is answer times 25.3. It's negative 0.18839, so do 10 to the 10 to the answer, or 10 to the negative k times 25.3, we get 65 times 0.648, and d is just 42.1 degree Celsius. And that is it for this question and probably the paper. And yes, this is the last of this section B, and all of these questions are straightforward. Possibly people will struggle for the log-based stuff because it's a bit more difficult, and as well as the radians questions, it's also not a lot of students can do radians well compared to degree, because we have been brought up teaching by degrees. And make sure you do change your angle unit on your calculator when you're doing different questions. Make sure you keep up with changing to radians or changing to degree, because it can seriously mess up the entire calculation. So yeah, that's it for this video. I hope you have learned something, and I'll see you on my next one.